that was the main cause of it. And so the recommendations, if you want to treat cholera or prevent it, you need really good ventilation. And another thing is you should wear wool to keep warm or something like that. Or and there's all sorts of, and the treatments are just ridiculous. They tried, bloodletting was tried, all sorts of things like that. Nobody knew what was going on. Nobody knew how to treat this or prevent it or what the cause was or how to deal with it. Lots of ideas bouncing around, lots of them very wrong. And this epidemic was then investigated by our great hero, Jon Snow. No, sorry, wrong guy. This Jon Snow. There we go, different Jon Snow. So this is Dr. Jon Snow. He rose out of absolutely nothing. His father was a coal yard worker, but his mother got an inheritance that allowed her to hook her son up with, because he went to school, he was particularly good at math. And so on the basis of that, got him apprenticed to a doctor at the age of 14. And was sent up into the north of England, and by the age of 18, when he began to see cases of cholera and began to treat cases unsuccessfully at that, by the age of 23, now he's got enough of a track record. He comes down to the University of London and earns all sorts of degrees, medical degrees and all sorts of things, and is really at the forefront of this great social movement of turning medicine from something which is more about folklore to something which is really a science. He pioneers a bunch of early studies of anesthesia. This is the age where people discovered that if you give somebody some chloroform, it knocks them out, and then you can cut into them and stuff like that. He actually studies, let's try different doses on people of different sizes, publishes some papers, becomes well known, becomes well respected. This is a smart guy. He knows a lot of stuff going on there. And he gets interested in the disease of cholera. This is one of the big things of the day. It had not been in London for that long. It's only been bouncing around for 25 years or so. So he treated his first cholera patients as soon as he was legally able to at the age of 18. He investigated several outbreaks of cholera after medical school. And he has his great aha, eureka moment. Probably somewhere around 1848, he figures it out. It's not the bad air, it's not the bad smells, it's not any of these crazy things. It's water. It's the water that people are drinking that causes. He shouts eureka, he figures he's got it figured out. He publishes a paper in 1849 arguing that no, everything we're doing is wrong. This disease is caused by contaminated drinking water, and that should do it. And the medical community is not convinced. His paper is met by crickets. Nobody really pays much attention to this because he didn't have really clear evidence behind this. And this is really important. And this is how the scientific process works. The fundamental assumption underlying all of science is that most people are wrong about most things most of the time. The assumption of science is that we're all idiots. That we have these great delusions and all these psychological studies about how everybody's walking around convinced that we have all the answers to all the world's problems, and if only people listen to us, the world would be a better place, and we're really good at remembering any evidence in favor of our worldview and dismissing or ignoring those against that. Welcome to the human race. That's what we are, all right? We have all these biases and prejudices, and we ignore anything which contradicts our carefully chosen worldview, and that's what science is designed based on. The whole scientific method, the whole scientific process assumes that. So how do you cut through that? How do you find the truth? How do you learn the truth about what causes something horrible like cholera when we all have our blinders and prejudices and preconceptions and all that sort of thing? How is there any hope of us knowing the truth, the facts of the matter? Well, that I can answer in one word. Data. Actual data are facts that have been generated in a systematic way so anyone else can verify and double check and say, yeah, okay, we got these things in an organized sort of way. Data is the fuel of science. That's what drives the engine of science forward and allows us to address and deal with all the foibles and prejudices that humans have, and we all have. If we gather data, we can do it. But the problem with data is it mostly ends up being like columns of numbers, and the human eye does not perceive columns of numbers very well. And that's why at the very beating heart of the scientific process is data visualization. figuring out some way to take your data, your measurements, your facts, your statistics, and turn them into something that we can see and conceive and understand, to turn them into a visualization that tells a story. That's how the scientific process works. I've been to all sorts of scientific conferences. If you go to the meeting of the annual Physical Society, American Physical Society, you'll see there are hundreds and hundreds of talks by physicists studying all sorts of things, and the center of every single talk is a graph showing them, showing whatever is being studied. That's the heart of the scientific process. Creating a good graph, some sort of visualization of the data to persuade the skeptic, to tell a story, to make us see something that we don't want to see, and see patterns as they really are. That's the importance of it, and that's what happened here. So there's this epidemic. So John Snow publishes his paper, nobody pays any attention to it, and he realizes he needs better data. He needs more evidence, and he needs to present it in a clear, powerful, and convincing way. So he starts gathering data. He's got a couple of studies going on, a couple of pots bubbling as he's trying to gather data. Then the Broad Street cholera outbreak happens, and he's ready. On day one, the instant he hears that there's an outbreak of cholera down there, he goes out the door and he's gathering data. He's knocking from door to door. Has anybody here had cholera? How long have you had it? When did you get sick? What happened? How have you been treated? What water were you drinking? That's knocking on door. Pretty soon people are evacuating the area, so you can't get all the things there. He gets in touch with a local pastor, Henry Whitehead, and says, okay, who lived here, who's been sick, who have you visited? He goes down to the London city offices, and they've got records of deaths and all these sorts of things, and he's recording all of his data. This is this is how it's got to be. He needs to get as much data about all these cases. The Broad Street outbreak ultimately leads to 616 deaths, about twice that many cases of cholera, about half or so of people got better. And then what did he do? Then he found a way to plot the data, which told the story in a clear, powerful, and compelling way. So I think this right here is the greatest data visualization of all time. So here's the whole thing he did. So this is a map of London. This is the Soho region of London, and Broad Street is right smack dab in the middle there. Over on the right here, we got a zoomed-in version of it, and every dark line here is a death. And they are located on the map. He takes the deaths, and rather than the ledgers and the notes and all the stuff he got from the city and from the pastor and from himself, he puts up a great big map, and he starts making lines where each death is. And what he finds is that, okay, you put all these things there, and then onto that map he puts the water pump right in the middle of Broad Street. And he finds that this is ground zero for the cholera outbreak. You look at this map, and then you look at the bigger one, and the details are hard to see. But you start looking at this, and you find that all those deaths are clustered around the region surrounding this Broad Street water pump. Now you see, this is because this is in the days before indoor plumbing. Even though this is London, this is the middle of, this is before people had faucets and all this in their houses. Every day, residents would go down to a water pump, fill a bucket with water, and bring it up to their apartment or that sort of thing for washing and drinking and all that. And he found, as he started recording the data, almost all of the deaths were within a very short distance of this particular water pump, the Broad Street water pump. He finds that of all the deaths that he records, only 10 of them were nearer to another water pump. And so then he asks them, and he investigates them and talks to them. Well, some people have left, but he was able to get details from 5 of those, and they said that, no, they sent someone down to the Broad Street pump because they thought that was better water. They liked the taste of that better. Others he talked to found that, well, they would, even though they lived closer to another pump, they're walking to school and work, and then they catch a drink of water on the way, pump the pump sort of thing like that. Even more than that, he noticed several interesting exceptions. Okay, so he's tracking down, he's accounting for every single death in the entire outbreak. And then he notices some really interesting omissions. Okay, so here's the Broad Street pump. Up here is a workhouse. I don't know if anybody knows what a workhouse is, but to summarize, that's kind of basically prison for poor people. So this is the poorest of the poor people who check themselves into the poorhouse because they will feed you there. But it's kind of like the Hotel California. You can't leave, and so this is serious. You would think if anybody's going to die of bad things, you think it's the people down at the workhouse, and yet they've got huge numbers of people living in very close situations meager diets to say the least, and yet there's only a couple of deaths out of all the people in the workhouse. So he talks to them. They have their own water pump. Fascinating. This is interesting. How about this? Oh, when we look just down look at this. There's one building here that has no dark lines on it. If you read the words across that, that's the Broad Street Brewery. So he goes down there and he talks to that. Well, there's a reason behind that. The guys down working at the brewery, they got a daily allowance of the product there, and so they never bothered to. They got free beer there. Nobody there bothered to go down to the pump. This is the smoking gun. To be able to go through the entire outbreak, to chase down each and every person, and to be able to figure out why these people outside of the region, okay, they went past the pump on the way to school or work, or these people inside there's a water supply in the workhouse, and the people in the brewery, they don't do that either. This was the smoking gun. This was powerful. This is amazing. To be able to take this data and to be able to lay it up in this way is absolutely incredible. With this, first of all, he immediately went to the city, there's a council, all this sort of thing, showed them the graph, showed him his data, made the argument, and based on this, they removed the pump handle. They took it off of there so nobody could get water out of that, at least temporarily. And persuading people takes time. But over the following years, more and more people saw this graph. There was a commission a couple months later after this trying to investigate, trying to figure out what's going on. Most people were in favor of the miasma theory, but John Snow was on this. He showed them the graph. He showed them his data. And one by one, he was able to convince people that this is not about bad air and you solve it with ventilation. This is about water. This is about contaminated water. And so over the next 20 years, this graph was shown to more and more people, gradually showing people. At the same time, the same year, 1854, the cholera bacteria was isolated and identified. And as a result of this, ultimately, the City of London totally redid their water supply and their sewage system, which at that point didn't even extend out to Soho and London and then other cities throughout the world. Cholera still exists in the world today. But for the most part, we find it in places where they don't have modern water treatment facilities. Because we know this, because of this graph, this visualization of data created by John Snow back in 1854 persuades people that we need to make sure our water is clean and well treated, and here's what we have to do in order to get rid of these bacteria. And this is still done today. This begins the modern science of epidemiology. Searching through when diseases appear, we put pins into maps. That's what he's really doing here. We see where it's coming from. What are the common factors? What are the exceptions that prove the rule? What's going on? This is used every day. This is used all the time and to track diseases. Everything from your seasonal flu to HIV. And here's one of the maps of Africa about an outbreak in Ebola. They're using the same techniques and the same methodology that John Snow used way back in 1854. This graph and its descendants have saved millions of lives. Thank you very much.
That is a rather hard act to follow, especially when the person presents the second greatest. So I'm sorry that you've lost. The greatest data graphic is now coming. So before I actually show you the graphic that I want to talk about, I just want to talk about data graphics or data visualization in general. So some visualizations tell tragic stories. I've got a couple of them here. So let's look at this one. 1986. Yes, I was alive then. I remember this. The Challenger disaster. Don't laugh at me. I heard it. Right? The Challenger disaster. This happened because of some O-rings, some seals on the booster rockets that failed due to cold. That was the visualization that the engineers used to convince people when you should launch and when you should not. I'm not sure that we can make a ton of sense out of this. I've spent a lot of time looking at this graph, and let's see, right over here we've got an O-ring that's got an H-type failure, heating, and that's a 63 degrees. Boy, okay, this is going to be cumbersome. This is going to be hard to read. if the engineers had just made a simple plot and extrapolated, there is a 100% guarantee, more or less, of a 36-degree launch resulting in a catastrophe. Had they just made a simple data visualization, we could have avoided this. But instead, no, we prefer that one. Whatever. Okay, tragic stories. Here's another one. It was essentially impossible to tell another human being how hard it was and how awful it was on the slave ships coming across the Atlantic. So this visualization was built to really demonstrate how horrible, how horrifying this actually was. And if you read some of the fine print, these people are being stowed under shelves. Data visualizations can really be a powerful way to show something truly tragic and truly that a human being is going to have a hard time grasping. Okay, let's go the other way. Some data visualizations tell compelling stories. Check out this one. So down the left-hand side, you see states in the United States. The warmer colors, as you read from left to right, they're kind of getting warmer and warmer. Those are more and more cases of polio in those various states. And you can see right there around 1950, between 1950 and 1955, there's polio everywhere. And in 1955, the polio vaccine is implemented, and blam, polio's gone. That's compelling, that's amazing. That's completely amazing. All right, this one, here's a cool data visualization that I think tells a compelling story. That's the internet. Those are interconnected web pages on the internet. And so another map of the internet, so all of these big dots here are different web pages, like that one, Google. Right? Nice big one right in the middle. And all the ones that are really close to it, there's Google. All the ones that are really close to it are things that are directly linked to Google. This is a really powerful data visualization. Right? Facebook's not too far away, and if you go way out here, we get, I have no idea what I'm clicking on. It's not going to load, so that's what web pages are. I guess we don't get to see. Right, what was that one? Something in China? Oh, yes, the number one ranked in China. Okay, great. So we've got good data visualizations. Oops. We've got tragic data visualizations, we have compelling data visualizations, and some visualizations are just downright amazing. They don't have to change the world. I'm sorry, Dr. Klein. Great visualizations don't have to change the world. They can simply be amazing in their own right. You ready? Greatest data visualization of all time. There it is. What? I know. You look at it at first, you're like, wait, what? There's a whole bunch of French at the top, and there's, okay, we gotta pause here and parse this thing out. Because I'm telling you, this is the greatest visualization of all time. This is Napoleon's march on Russia. This is the 1812 to 1813 winter march on Moscow, where Napoleon's saying, okay, look, Russia, I am tired of you trading with the Brits. I've had it with you. I'm not just taking over Europe, I'm taking over you too. Here I come. And so he starts over here with 400,000+ people over there at the edge of Eastern Europe. And the width of this brown bar here is how many troops he has. And as you start reading from left to right, you can see that there's little notches coming out of there. He's losing troops. I actually have a visualization of the size of Napoleon's army as he's marching into Russia. And you can see that there's another little group that kind of splurs off. And way over here, the black is the return trip. And the width of this thing is the size of the army. Yeah, that's exactly the thought you should have. At the very end, look at that tiny little thing over there. Napoleon's got 10,000 troops at the end. He started with over 400,000. This is hands down the best data visualization of all time. There are 6 variables happening here simultaneously. So we've got the width of the band here is the size of the army. There's one. This is geographically accurate. If you overlay this on a map of Eastern Europe and Russia, this is basically where he went. So I have a latitude and longitude. There's 2 more variables. The color is actually telling me which direction we're headed. So the brown, I'm heading into Russia. The black, we're heading out of Russia. So I've got direction. There's another variable. And down here at the bottom, we'll go back one there. Down there at the bottom, we have the temperature of the horrible winter that they were marching through. For reference, I realize that's quite small. Let's try this. Might be slightly better. For reference, that line right there is 0 degrees Celsius. That's the freezing point of water. This was a cold winter. And we also have time on this. 6 variables all at once. It is really hard to get 6 variables on a graph and have the graph actually be meaningful. So let's look at this from the French point of view. The individual who created this graphic, Charles Menard, he is a French civil engineer. He's actually retired. He made this for fun. He actually made this in 1869, I believe. Yeah, 1869. It says right up there at the top. This was just a retirement project for him. But he's French, so let's see. Maybe this is from the French point of view. June 22nd, 1812, 400,000 troops begun marching on Russia. Napoleon's going to take over. The Russians know he's coming. Napoleon pushes forward, but he does so with no supplies. He's kind of being bold about this, and he's saying, all right, look, we're going to march into Russia, but as we do so, we are going to be eating all of their corn, drinking all of their beer. We're going to be pillaging different villages to get bread and to get supplies. We're not actually going to have a supply chain. 60,000 troops break off to take off some other strategic initiative, but you can see the little notches here. The troop size is dwindling. And actually in the French up here at the top, it says on the original scale of the picture, for every millimeter notch, there's 6,000 troops that we decrease. Now, obviously, it's not a millimeter up there. We know how scaling works. All right, so fast forward to August. We run to Smolensk. The Russian army does something really interesting. They know that Napoleon's coming in with no supplies, and the Russian army says, great, bring it on, Frenchies. And then they burn the thing to the ground. And then they just back off a little bit. It's a scorched earth policy. So they basically are burning villages and burning all the crops. And the French are now marching on empty stomachs. They have no supplies and no way to feed off the land. And by the way, at this point, the French are already down 300,000 troops. They've lost almost 3/4 of their troops already. All right, fast forward a little bit more. We're getting really close to Moscow. Napoleon thinks we're actually going to do something. And there's this horrible battle at a river, the Moskowa River outside of Moscow. It's a 3-day battle. There's no real clear winner. There's casualties, mass casualties on both sides. The French are down to 100,000, so they've lost 50,000 or so troops near there. Okay, we get to Moscow, and nobody's home. The Russians knew he was coming, and just said, all right, look, all of you Russians, flee to the countryside. Get out of here. We'll let him have Moscow. He's not going to have a win. Right? Because there's nobody here to actually defeat. So the legend has it, I mean, Moscow burnt, that's not a legend. The legend is that Napoleon's troops are just kind of looting, and all of a sudden the fires break out because Napoleon's troops are just being hooligans. Napoleon himself stays for a month. I mean, he's sitting there like, this is great, I want my victory. I don't have any Russians to celebrate over. So now let's start returning. Winter comes early. And it's cold. And Napoleon himself is just like, all right, you know what? I'm not going to go back with my troops. I'm back. I'm heading back to Paris. He's gone. Right? So really the black lines here are just the troops themselves. They know they can't return across the same land that they already marched across because it's burned. And now it's almost winter. And the French are continuously engaged by the Russians. And I've said this a few times, it's really cold. And they have no supplies. And people are dying of starvation. People are dying of exposure. The Russians are still engaging with them. There's this river crossing where we lose 20,000 troops. But if you look, it's also negative 20 Celsius. Yeah. This data graphic is amazing. All right, we keep pushing forward. At the very end, we're down to 10,000 troops. There's so much information sitting here. This is the story of the beginning of the end of Napoleon. Hands down, the best data graphic that ever existed. I'm sorry that yours was second best. Like I said before, there are 6 variables shown at once here. All right, we got latitude, longitude, size of the army, temperature, direction, and time. Now we can look at this in another way too. Let's look at it from the Russian point of view. So you might be familiar with the 1812 overture. There we go. We got some music to go along with this. All right. Tchaikovsky is trying to set the mood. Now this is from the Russian point of view. The Russians are somber. They don't really want the troops, or 400,000 troops, to advance into their country. But they know this is coming. So kind of the legend is that the Russians are gathering in their churches and praying. And if you listen to Tchaikovsky here for a second, this is really setting the mood of what the Russians are doing. Okay, now let's fast forward. There we go, all right. As we're advancing on Moscow, you'll notice that the pace of the music starts to pick up. We're trying to mirror how the Russians are feeling about this advance of Napoleon's army. He's trying to paint this picture of the calm before the storm. All right, and a few more minutes in here. Obviously, I'm cherry-picking. We're not going to listen to the whole 15-minute overture. All right, there's a battle that's ensuing. The pace of the music has really picked up. And the Russians are engaging the French. And there's massive casualties that are happening all across, on both sides. All right, this battle goes on for a while. Notice that goes on 4 minutes 45, now it's 10 minutes. Tchaikovsky really likes that battle, apparently. Fine, we'll give him that. All right, fast forward into about 10 minutes. All right, that's it for a second. The French national anthem plays there because Napoleon marches into Moscow and thinks, hey, I've won, nobody's here. And all of a sudden the somber mood comes back here. Napoleon's got nothing to celebrate because nobody's there. All right, hopefully no more acts. All right, let's come back to about 12 minutes into the overture here. The Russians are taking over. Yeah, here comes the French fleeing and they're running away. We got this descending music of the French fleeing Russia. We go a little bit all on this one minute graphic. For helping me with some of the history, and Arizona Duck for helping me translate some of the French.
Questions for Dr. Klein, questions for Dr. Sullivan? Any questions about anything, preferably about the talk? And we're going to make this a little bit more intro. Right. Where we at? Yes.
Dr. Sullivan, do you know of another example of that type of graphic?
It's funny you ask. I was prepared for this question. Menard was busy. He actually really enjoyed making these graphics. So this is the cattle sent from all over France to be consumed in Paris. It takes a little while to parse what's happening here, but all of these are, I believe, all the counties in Paris, and the pie graphs are telling us how much cattle are being harvested from there and sent to Paris. He's got another one. I think I only did 2 in here. One of his other graphics. This is the traffic density between Dijon and Mulhouse. And this is actually the same type of graphic. The size or the width of the lines here is how much traffic is actually on this. This is not traffic in the way we think of it. This was made in the 1850s. And actually, if you go to Charles Menard, the Wikipedia page for Charles Menard, there's a handful of these. He did a lot of these. We'll go back to the greatest one.
You have some more Menard things compared. Do you have, for example, any of the graphs that say the data science class made when they tried to combine 6+ variables in one graph?
So, okay, to fill everybody in, so John's question is, in the data science class that I'm teaching, I gave an assignment where you were supposed to make the worst graph possible. I gave you gave them all a data set and said, get as many things on this picture as you can. I think the record was 8 different variables all on the same picture. They were horrified. They were completely horrified. I stopped short of putting any of them here because I didn't want to scare anybody.
It was great.
It was a good exercise.
For Dr. Klein, he said he's got 6 variables. How many were in your plot?
Well, we certainly have latitude and longitude. The mortality, there's deaths, and there are other features on there. But in terms of just raw variables, it's hard to lay a finger on them.
All right, what else we got?
So this is a question for both of you. You both made relatively historic topics. Sure. In the 1800s. Why did neither of you pick a more modern topic?
Always looking for impact. And, the farther back you go in history, the more time there has been for something to have, to percolate out and to have things that resulted from that. I'm sure there are data visualizations going on right now which are going to have amazing impacts on the future. We won't know that, so we'll have to reconvene in 200 years and then
So certainly by that logic, a graph made, say, about 1812 would have more impact than
It was made in 1869.
All right, other questions?
Well, hold on. That was for both of us. This one in particular struck me because there's another historical fact here. So I don't want to go all the way back in the slides, but way over on the far side there, where there's 400,000 troops for Napoleon, up here on the best graphic. That was June 22nd of 1812. Now in 1941, on June 22nd, what did Hitler do? The exact same darn thing. Exact same day, obviously many decades later. History is bound to repeat itself, I suppose, and in this case, it's very serendipitous. It's really the same calendar day. And that struck me as kind of an interesting, neat coincidence. Then, of course, there's 6 variables here. There's so much going on. It's really a rich graphic. So, the historical significance, the graphic itself, the irony of Hitler making the same mistake. It's something to me.
Sounds.
All right, what else we got? Well, you just asked one, right?
Yes.
You want to ask another one?
Yes.
All right, go ahead.
So, Dr. Sullivan.
Yes, sir.
So you were talking about 6 variables, and that's why it's the greatest data visualization visualization.
No, the 6 is not why. The
Well,
6
but-
is just a contributing factor.
It is a contributing factor, but it makes a contributing
Sure.
factor. So, why not use something like Google Maps? If your timeline is treats, it has nearly 6 variables and almost same impact.
All right, next debate. That's a good idea, sure. So we could, using some of our modern tools, overlay all sorts of modern events like this on top of Google Maps, and we could actually recreate a Menard-type graph for civil wars that are happening right now. If we've got the technology to do it, it's actually probably not so hard to do. It's a cool idea, love it. Anybody in my data science class, don't worry, their homework's already set.
For Klein, could you not also take the information that we got from like the deaths and things and make it available to people on sources like Google Maps? Like, hey, there's like a contamination outbreak of this. This should be something that the public's aware of.
I think that's amazing, that we have these tools available now, so that in real time, we can take this data, which is being collected by governments and people all around the world, and to be able to do that in a live sort of way, it is just incredible. The tools we have available, the things we can do with them, just difficult to even discern. I think that's what makes data science such an incredibly amazing and interesting field, because we're just scratching the surface of what we can do. Now that we've got all this data interconnected with the internet, and you can add these things and overlay things, and Google Maps and all these different tools. I mean, where this field is going to go in the next 25 years is going to be incredible to see. I don't think anybody knows what we can do in the next 5 years. Yeah.
Would you each both address maybe the, I'm not sure I can phrase this correctly, but the relative difficulty for the individual creating the graph in their time, in their real time? So, for example, I guess this graph was made 50 years or so, whatever it was, after the events. In the comfort of retirement, for taking.
You're right, so he was in the comfort of his retirement. So in the French text here, Arizona helped me translate this a couple days ago. He actually cites all of his sources. So this, so in here, the capital letters are all, these are all individuals in which he was pulling the data from. And there's a doctor that he also was pulling data from. And he actually cites the day in which he was doing that. So he did some personal interviews in order to actually get this data. And then he was looking at historical record too. So was this as hard as Jon Snow going out and risking cholera to get his data? Certainly no.
Yeah, Jon Snow's gathering his own data, largely. Some of it he was able to get from the offices here in London. But for the most part, he's knocking on doors, he's talking to people, he's chasing people down.
During a cholera epidemic.
He was not taking
Used to make better choices.
Yes, oh, absolutely. I had one. There are numerous examples. Once this is done, once Jon Snow makes his graph and makes his point, and people realize the power of this graph, this becomes a standard tool in epidemiology. This is used all the time, everywhere, to track all sorts of diseases. This is one I pulled off the World Health Organization website through there with where they're tracking the outbreak of Ebola in Africa a few years ago. This is a standard tool now. This method of putting things up and seeing the geographic relationship between data and the locations and then trying to look for common factors. This is now what's done. That's chapter 1 of epidemiology is Jon Snow.
She did that from Montana, because I was exposed to these mice, and antivirus, and nobody knows, but in the last 26 years, there's only been 44 cases. So I was interested to know throughout time when most cases happen, so if it's not recent, then I feel better about that.
So, question for both of you. This was a debate about data visualizations.
Yes.
However, I would say that in both cases, you presented a very compelling story based on a graph, and you had to do a lot of explanation for the story to come across. So was this really a debate about which data visualization was most effective, or which of you was able to tell the most compelling story.
I can show you John Snow's graph.
Yeah, and if you look at Jon Snow's graph, it's the most boring graph. There's not much going on until you know some of the details. I could find this right on that, but I mean,
You can't even read Bernard's graph unless you know French.
True.
So, kind of an offshoot of that question, for both of you, what value do you place on ease of readability of the graph in terms of your audience, and how do you defend YouTube graphics and that stuff? I would argue it's the most.
so now that we know the answer to the question. Ease of readability of 6 variables simultaneously, that's not going to happen. It took us a few minutes to parse this graphic. So, is it the easiest thing to look at and instantly know what you're looking at? No, of course not. But once you get into it, once you know some of the fundamental features or the aesthetics in this picture, it's actually not so hard to read. So I'd argue that giving yourself just a little bit of cognitive time, this is actually relatively easy to read. What?
Yeah, a graph tells a story. I mean, it takes the data, which can be represented with columns of numbers, and and nobody gets anything from that, and presents it in such a way that the human mind can see what's going on, to be persuaded of something, and see something maybe nobody wants to see, to be persuaded. Even if I believe in miasma theory, I look at that graph, and the organization of the data, presentation of the data is so compelling. This was what changed minds and allowed people to really understand.
So both these graphs show something that they were able, like data that they were able to collect that happened previously. So one of them was 50 years later, and one of them was people dying at that time or people who had already died. But how do these help us predict things or understand features like moving forward more? And you've touched on a little bit, but for both of you guys, like what are some more predictions or things that we can pull from this that help us in other fields?
Maybe Russia's a bad idea.
I can say one thing. I am surely glad that Hitler did not know of this image. Or if he did, he didn't pay attention to it.
I have a question. It's a little off topic, but it's back to topic. As someone who's almost 50 years old and seeing the impacts of social media, instantly we can say these are some of the impacts that you talked about. We can analyze data really fast. How long before we really see the impacts? And with people having that at their fingertips, why are we ignoring it?
So I
You know what I
think
mean? Just the relationships not being as strong, not being able to have those interpersonal impressions on the rise because of social media when it's supposed to make it better. That type of thing. You see
so
what I'm saying?
this graphic here
Yeah.
is a partial answer to your question. So this is the map of the internet. I put map kind of in air quotes because it's organized in kind of a special way. But people at Google, people at Facebook, people at Twitter, people who are using the internet to actually peddle whatever it is that they're making money on, are actually studying exactly what you asked. They'll watch a social trend propagate through a social network, and you can measure the mood of the country by actually visualizing how, say, a tweet will propagate through this network. So these sorts of visualizations are actually used all the time, and I hate to say it, people are making boatloads of money off of you by making visualizations like this and learning something about them.
Well, and they are, but
They are.
sometimes people that are addicted to it that don't realize the negative effects aren't utilizing it.
It's true.
I'm in a room with colleagues today, so I'm trying to
I think this goes back to Dr. Klein's point about the fundamental assumption of science. Most people are wrong most of the time about
Most everything.
People build up their own view of the world. I think it takes the appropriate use of data to break that.
For Dr. Sullivan, has anything come out of this style of visualization that you've shown us? Like with Dr. Klein, he shows there's like it's proven to be a way of mapping diseases and stuff. But like what's kind of come out of that? It just seems like it was more for fun.
Pretty graphic. But looking at it from a historical perspective, this gives you a really good sense of what happens on Napoleon's invasion. Like if you actually want to understand it, you can literally start here without reading a textbook, without listening to any lectures, and you actually understand kind of the big picture of what happened during that whole invasion. Then if you want the nitty-gritties, now we pick up a book or we take a history class, and Dr. Block is back there. He's waving. This just tells a really fascinating story.
You guys just play rock, paper, scissors for the win at this point?
Well, we do have voting. Shall we go to voting?
For Dr. Klein, all the people that run the breweries and never like just drinking beer, don't they have to use water to make beer?
Turns out, in the process, first of all, the brewery had its own water, and in the process of making the beer, they boiled the water. And that takes care of your color.
So did anybody at that time look at the graph and they didn't like the water theory, so they said, we should all be drinking beer instead of water?
All right, are we ready for the vote? You have one more question, John?
Since we've established that this whole debate really just comes down to what you value more in a data graphic, whether it's the skillful use of data science to show a whole lot of data all at once, or the positive.
Obviously data.
Okay, so if you're in the audience and you've got a phone that can scan the QR code, that'll take you to the voting. If you are on Facebook, the voting link has been sent to the comments on Facebook. Is that right, Sam?
Yep.
Okay, so you should be able, if you're on Facebook, you should be able to just click on that link.
Did you get it?
You made a really good point about that. I mean, the one with the super. Yeah, the one with the super. I actually don't know. It's like, we're rap, but like, it's not like the most debating it. I love it. That's probably my favorite song.
Just has people that don't have Don't tell them. Make it easy. Don't tell them. I don't even know. But it's a data video. And you can only hold one.
I'm told that you should see a red light when it's registered to vote.
So you can go ahead.
Oh my god, I'm going to kill whoever this is. I'm going to actually murder them. Who is it? I have an idea. I think it's this group of boys. Right? That's exactly what I think. Yeah, either way. Alright.
Did you notice that both GIS are
Any final
It's not better. It's just sticking with
Having voters remorse.
And then online votes really said the same thing as the in-person votes. The winner of this debate is 1A, Dr. Kelly Klein.
The greatest data visualization of all time.
Thank you for coming. We love putting these on. We're so glad that you come. This was actually.